Welcome to clickmyproject.com. Let we discuss about the process breast cancer histopathology image analysis, a review. Let we see the abstract of the process. We propose a method for computer aided histopathological evaluation using mass spectrometry imaging. Specifically, mass spectrometry imaging can be used to acquire the chemical composition of a tissue selection and hence provides a framework to study the molecular composition of the sample while preserving the morphological features in the tissue. The proposed classification framework uses statistical modeling to identify the tumor type associated with a given sample. In addition, if the tumor type for a given tissue sample is unknown or there is a great degree of uncertainty associated with assigning the tumor type to one of the known tumor models, then the algorithm rejects the given sample without classification. The input tissue images were basically preprocessed by Gray conversion and median filtering. After that, the GLCM features were extracted from the input images. The extracted features were then classified using adaptive neurofuzzy interface system to denote the different defects in the input tissue samples that we have obtained. ANFIS is a multi-classification methodology, hence we can calculate up to different types of diseases in the tissue samples. Finally, the accuracy of the process is measured, and based on that, the performance of the process is studied. Let me see the flow of the process. The input image is initially preprocessed by resizing and Gray conversion of the image. Here in our process, the input images were the tissue samples obtained, the images were collected and they were in color format. They were converted into gray and median filter is applied to the images. This is the basic pre-processing steps employed in the proposed method. After that, the denoised image is obtained. This image is used for the detection of edges. Based on this, the features were extracted along with the other features. So, for the detection of edges in the input images, the Canny edge detection methodology is employed. The Canny edge detection methodology uses an operator which is helpful in the selection of the pixels and the removal of the unwanted regions in the input images. After the detection of the Canny edges, the features were extracted. After the feature extraction, the features were texture based informations retrieved from the images. So this texture will be the same for similar type of images, and hence for this the GLCM features were extracted along with the Canny edge detection methodologies. The extracted feature values were combined and they were used as the texture features. The same process is repeated for the some set of images in the datasets, and that images were used the training processes. After that, the extraction of the texture features, the training processes. After the training process has been completed, the values were given as input for the classification method. For the classification of the signals, we use ANFIS classifier. The classifier classifies the input tissue samples into normal or abnormal based on the labels provided for them in the classification methodologies, and we use ANFIS classifier for the classification processes. So in this processes we have calculated the features and we have classified the features based on ANFIS processes, and the performance of the process is measured in terms of accuracy, sensitivity and specificity of the process. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface for the execution of the process. The user interface contains display accesses and buttons for the running of the process. So these buttons and displays were present in the user interface for the execution. So we select any one of the input image which is present in the dataset. Since this process is a trained processes, the results will be accurate for the trained sequences. So first we select any one of the input images. After that, the pre-processing step is employed, in which the gray conversion, resizing and filtering is applied. After that, the edge detection is employed. So in edge detection, the canny edge detection operator detects the edge regions in the input images, and then half transformation is applied to the images. This half transformations identifies the textures based information in the images. So this texture based informations were extracted, and after that the GLCM features were extracted. So this is the texture based features extracted from the input images, and after that we classify the input signals. So this image is classified as a normal image. So this classification is employed based on the ANFIS classifier, and finally the performances of the process is measured. The accuracy, sensitivity and the specificity of the overall process is obtained as the performances, and they were displayed. Thus we have taken the tissue samples as input, and we have pre-processed the tissue samples based on gray conversion, resizing and filtering. After that, the edge detection is employed based on canny edge detection operator. Finally, hub transform features and GLCM features were used for the texture based feature extraction from the input tissue samples, and after that the classification of the process is employed based on the ANFIS classifier. Finally, the overall performances were measured with the help of accuracy, sensitivity and specificity.